Hi, so today I'm going to demonstrate the methodology to calculate the elastic and plastic strain in a CAM clay model. This is the examples are composed of two parts. The first is the problem 2 of week 6 practice class, and question B here, it's actually a very typical example of that. The second example is from the assignment. All right, so in terms of first example, we have to first go through what is going on here. The thing is that the soil is has the pressure initially as the first onset of yielding to 200 kilopascal, which is here, and then it is isotropically loaded in drain condition to 150 kilopascal, which means that the stress pass changes from 200 kilopascal horizontally to 150 kilopascal. And then it undergoes a triaxial drain test. That means this is 3:1 ratio, and it's increasing from A to C and touches the CSL line. Okay, so the procedure we try to calculate the total strain, or the elastic strain and plastic strain, is going on like this. So firstly, we have to calculate the initial Q and P dash. So in this question, because it's from A to C that we're talking about, we're actually interested in. So the initial Q is 0 and P dash is 150 kilopascal here. And then we find the yield surface, which is actually the yield surface here. That means the yield surface corresponds to the initial condition. So because we have 200 kilopascal here, so it's very explicitly shown here as 200 kilopascal yield surface. And then the next thing we need to do is to calculate whether F is smaller than 0 or greater than 0 after the increment from A to C. So generally we plug the end of increment load into the equation F equals to Q squared minus M squared, blah blah blah, and then this yield function is actually determined from this, and we plug the end of increment load by Q and P dash here in this function. And in this problem, we actually found that there are actually two stages. The first stage is A to B, which is elastic strain or elastic deformation. And for this single elastic deformation, we calculate from A to B. That means we're actually from QI and PI, which is Q equals to 0 and P equals to 150 kilopascal, to the point B, and we can derive this point from this plot. After this, the stage B to C is a elastic and plastic strain. So therefore, we need to calculate both components. So the procedure is actually here. As you can see, first the elastic strain A to B, and it's 150, 0 to this, and we plug into elastic stage formulation, and then it's easily derived. And one thing that is worth noting is that when you plug into the formulation, this parameter, this matrix, is actually the initial condition matrix, and the matrix by the side, which is delta P dash and delta Q, is the incremental stage matrix, which generally means the change that happens with respect to the initial state. So this is a very important concept when you try to calculate the strain, and it's so in calculating this initial condition, we plug in the initial parameters, which is here 150 kilopascal here, and also corresponding VA. Sorry, it's new A. And also G is the same, except that this is the Poisson's ratio. And then delta P dash and delta Q are generally obtained by subtracting these two values. Okay, and from B to C, we have to calculate both elastic strain and plastic strain. So when we're calculating from B to C, the first initial state is stage B, where we have to plug in the number of, or the parameters of corresponding to stage B, and it's here. And the increment is from B to C, which is this matrix minus this matrix, as shown here. And therefore, we have to calculate the nu corresponding to the stage B, which is also very important because you have to plug them in both elastic strain component and plastic strain component. And then the calculation is demonstrated here. Okay, this is for problem 1. And problem 2 is that we have in assignment. Firstly, it's at the imminent point of 400 kilopascal, and just undergoes a CD test, which is the 3:1 ratio, and then it goes from, which is called stage B, it goes from here to here, which obviously goes through an elastic deformation. So therefore, for stage A, the initial condition is 400 and 0, and the condition here is somewhere here and here. And then the stress pulse when it goes back is so in stage A we have to calculate both the elastic component and the plastic component. After that, in stage B, because it's composed of only elastic strain or elastic behavior, we only calculate the elastic strain here. And the initial condition is this point, and the changes from here to here, and that's it. This is very easy. And the last important thing is that how to calculate the yield surface. Okay, so the yield surface is that when you go from here to here, for example, this yield surface, it is calculated by this point as you know it, because this point is actually on the CSL line. And on this point, you have the number of P, the number or the parameter of Q, that of P dash and Q, and you plug that into it to back calculate the P naught or the P0 here, and so that you know what is the yielding function of the yield surface. And that's it. Thank you for watching.